Thank you everyone for joining another ecosystem code session. It's really exciting to have these as we build and also grow the product and share what we've been working on our side, and to see also how it can translate for the users as well throughout the journey. So yeah, today's session is meant to be as practical as possible, but also to understand the context within software development that we're working on at the moment. And I want this discussion to feel like a fireside chat, as if we're right next to you working through the demo and all the developments that Jay will be sharing with us throughout this product, and why infrastructure consistency has become such an important problem in AI-assisted development. And the goal of these demo sessions is not just to showcase the tooling, but also to explore the bigger idea around how AI is generated, how it's deployed, and also how it's maintained, especially in an era where the AI can create an entire application and not just the isolated snippets of code, which can create a sense of disconnectedness for us as a whole. So I want to jump into the agenda to give an overview of what this discussion will entail. And we'll start off by unpacking one of the biggest problems in AI-generated software today, which is why are so many impressive looking apps failing the moment that they leave that stage of being a demo and in production. And we'll look at what actually breaks between local development and production, and also just that team collaboration, and why infrastructure consistency has become rather one of the biggest unsolved challenges in AI generation today. And then from there, we'll introduce the operation advantage of adopting an intent-first architectural approach using ecosystem code. So instead of treating architecture as something that is patched together after the generation process, we'll look at what happens when that infrastructure and deployment targets and the environment behavior and just the system structure as a whole is defined upfront as part of the application's blueprint. And then from there, we'll move into the live demo by Jay. And this is where things will get a lot more interesting, where we take a plain English system description and we turn it into a coherent full stack application. And we'll look at the generated stack, inspect the specification layers, run the application, and test it across different environments. And then from there, we'll open the floor for discussion around the architecture itself, the future of deployment consistency, and infrastructure generation as we know it as a whole. Cool. So the first thing that I want us to look at and try to understand is, why are AI-generated apps breaking between the environments? And I think it's important for us to begin by setting the scene and contextualizing the space and the considerations that come into play when you're operating from this point of view, because a lot of these systems look impressive during the first 5 minutes. You've been building something for a couple of weeks, you've used a tool, whether that's Cursor or Codex, and you've described what you've wanted over time. It's built it for you and it looks great. It runs on your computer, and when you click through it, everything works. However, when you want to push it to a test server or to a larger environment, that's when things stop working and there seems to be a disconnect. When we can see things like your application not connecting to the database, or the passwords are in the wrong place, or the settings that worked on your machine don't exist in the server as a whole. And that is something that you could have missed from the beginning. This is something that we see quite largely in the space, and it's not a new problem. It's something we've been dealing with for the last couple of years, and we've invented so many tools and sources to try and solve this problem. But right now in 2026, it seems to be something that is getting worse as we continue to see the dependence on AI-assisted development across the scale and even the scope of building these tools. So because AI can now build an entire application in minutes, and they tend to work fast, which tends to incentivize a lot of this process, there's also these old assumptions that deployment is something that you worry about later. And by deployment, we mean making your application available somewhere other than your own computer. This could be on a cloud platform for millions of users to reach it. And so you want to think of going away or veering away from building first and then figuring out deployment at a later stage. And this sequence of development is the root of the problem. And that is the process that development and system orchestration is at, and what we're hoping to change with ecosystem code as a whole. Cool. And from there, we want to understand what it takes to work in this space and also generate applications as a whole. And the answer that we see is that there's a lot of speed in this space, right? There's speed to prototyping, there's speed in getting a UI scaffolded in minutes, in iterating on a quick idea before you commit to anything. And for getting something to work fast, these tools are genuinely capable. But there's also a set of issues that arise if we don't get them right. Firstly, portability, which means whether the app can run reliably across different environments and not just the machine that it started on. And when we say things like secrets hygiene, we are asking ourselves how securely the systems handle sensitive information like API keys or passwords or database credentials. And when we say authentication, we're asking how securely are users able to log into the application and how are permissions managed. And when we look at infrastructure assumptions, what are the hidden assumptions about the servers or the databases or cloud service or even the deployment environments that are baked into the code that are not quite clearly defined, right? These are not small technical details. They become critical the moment the application needs to exist somewhere other than the laptop itself. And it is this reason that we see tools struggle with, not because the models are bad at coding, but because of the structure they operate in, right? Most AI coding tools generate from the last few messages that they can draw from. And the model looks at the recent context, it makes its best guess about what the full system is supposed to do, and then it produces the output. And that works fine for a single feature in a single session. But as projects grow, there's not only a single document that describes what the system actually does, there's more to it as well. And these things where there's no single source of truth, where there's new sessions and there's slightly different assumptions that build onto each other, this can lead to architectural entropy, right? Where the application looks fine on the surface, but underneath that coherence is slowly degrading, where different parts of the stack make different assumptions about the same things, and the decisions that are most expensive to get wrong later, such as where the app runs, how it handles its secrets, how it packages itself for deployment, these decisions are never made explicitly, and they can happen at a stage where it can cost more as a whole. And that then connects us to what we want the solution to look like as a whole. And that then leads us to understanding intent-first architecture. And from this understanding, we are able to see the need for a shift from just building first and figuring out deployment later to rather starting with the blueprint. We want to ask the question, what does the architectural layer, what does the blueprint layer look like in practice? And with most AI development workflows today, the way in which they're structured is that they have a chat first. And what most people think of when they think of AI-assisted development is that where you write a prompt, build me a user authentication system, and then the model then receives the prompt and generates the code, and then you get the code. Even now, that is something that we want to challenge in terms of how we approach it as a whole, and to understand that there needs to be an asking of the right questions, right? Where is the system going to run? How will it handle the credentials? What happens when it gets deployed to a server that has never seen this specific configuration, right? These are the answers that were never specified. And if the AI is the one filling these gaps, which is usually what happens, there tends to be bad habits that are baked into the code by default. And so the note that we need to understand is that without having that architectural context, you can lead to hallucinated structures and inconsistent outputs each time the code itself is generated, right? And we see this quite prominently in hallucinated structures or drifting schemas, right? And by drifting schemas, we mean that the fields that exist, what they're called and what type they are, they change slightly over time, and there's a need for you to add something new, or there's a lack of authoritative definition as a whole. And we want to challenge this by adopting the ecosystem code workflow and to understand the difference in this approach as a whole. So the first stage with ecosystem code is not just prompting, but it's the architecture. So before the AI sees anything, before a single line of code is generated, the system starts with a structured specification, and that is the UML, and that becomes the blueprint. And so what ecosystem code does is that it generates the specification from plain English requirements, and then it generates the code from those specifications. From there, the platform produces the code for you. And what the specification captures is, what does this system store and how is it organized? What happens step by step when a user does something? What changes can something move through, right? What triggers each transition? What parts of the system talk to other parts? And critically, where does the system actually run? Which environment, which infrastructure? All of these decisions are made upfront and they are structured so that the code gets generated from that plan and it's not the other way around. And this is what intent-first architecture is about. It's about what your system is meant to be, and it's planned and built throughout as a whole. And this is seen modeled through the UML diagrams on the workbench, right? This could either be a class diagram that shows what your app stores and how it's organized, or a sequence diagram that shows what happens step by step when a user goes through the workflow. You have state diagrams, for example, that show what stages something can be in. So for example, if it's an e-commerce system, you can look at orders going from placed to shipped to delivered. And that's what allows it to go through those different stages when it is structured and outlined in the system as a whole. For example, you could also have activity diagrams that map out the full user journey from start to finish. And together, these diagrams then serve as the blueprint. Once that blueprint is complete, the system validates it before a single line of code is generated. And so what do we mean by validation here? Validation is the check, right? The system looks at the blueprint and asks, is there anything missing? Is there a reference to something that hasn't been defined? Is there a workflow that has no ending? Are there any gaps that need to be flagged and fixed? And these are not discovered later when the app breaks in production, but it's discovered in this planning stage. So once that blueprint is validated, everything gets generated from that. And this is the part that matters quite strongly for this discussion today, because the blueprint already defines where the system is supposed to run, whether that is a local machine or a cloud platform. So when your team is moving an application from one environment to another, they don't need to rewrite the application as a whole. They're simply giving the same application a different set of configuration values to run against. And this is what we call the deployable without modification, one code base that is consistent across those multiple environments. And this connects directly to the idea of consistent code generation. And the emphasis here is really on the word consistent, as this means that it is consistent across every environment and also consistent with the system itself. And this means that all parts of the application agree with each other and they work together according to the same architectural rules, right? You have the front end that expects the same of the API structure that the back end actually provides. You have the authentication system that works the same way across every service. You have the database structure that matches what the application logic expects. And this is something that lacks quite pertinently in inconsistent systems, where you have different parts that are often built from slightly different assumptions, where one component may expect one naming convention, but also another could be using a different one, right? And these mismatches can then lead to deployment failures as a whole. And so to say that a system is consistent with itself, we mean that the generated application behaves like one coherent system instead of disconnected pieces that are generated in separate sessions. And so this is how ecosystem code executes against that architectural intent, leading to coherent, consistent, and also auditable systems every time. And so this means that you can inspect any part of the generated system and trace it back to the decision in the specification itself. You can ask questions about, why is this service here? Why is this infrastructure configured this way? And that level of traceability is very difficult to achieve in purely chat generated systems, where many decisions emerge implicitly over time rather than being formally defined upfront. And so with that context, we are hopefully established when it comes to understanding what it takes to keep that consistency at play when you are deploying your applications across different environments. And now we are going to move into the demo, actually see how a system then functions. And that is Jay going to take us through that section, starting with a plain English description of an application and moving through the architectural scaffold, the full stack code, and also the deployment configurations as a whole. And then we'll validate that by actually running the applications across different environments. Over to you, Jay.
Thanks, Christina. Great context. So I'm going to grab the screen share. So what I'll take you through are basically a series of steps that you normally would follow to achieve this. And if you don't use a deterministic style of AI design, probably 95% of your work is going to happen again and again, and it causes an enormous amount of challenges for you in the deployment of whatever you're working on. So in this context, if you go to the ecosystem website and you sign in, once you signed in, you'll be able to see either the App Studio, and the App Studio is a conversational style way for you to work with your projects, or you can use the other approach that is just a dashboard that you can go and, like Christina was saying, where you can start your project from. What you'll notice here, it showed that some of these apps are already hosted, and we will go through those in a second. But the big thing is that when you generate a new app, whatever the app is that you want to create, you'll see that this quick start generator features that we just brought online recently is the first thing is bring your own data, and the second one is upload an ontology. So if you go and find an ontology about a particular discipline or about a particular company or an approach, you can provide us with that, and we will extract all of the intelligence that we can from there to make sure that the base architectural structure is essentially generated in a way that is highly reliable. The second thing is if you bring your own data and you want to connect, you can pick normal SQL databases, or you can provide it with a MongoDB connection string. If that Mongo runs in any of your cloud infrastructures, whatever it is, it'll go and extract that. And whatever the entire structure is that is being generated will then be able to use that database that you have provided the design for, depending on how you want to run the app then going into the future. So you might just want to enable an existing application with MCPs or agent-based capabilities, because what we will do is we will generate already AI-enabled infrastructure upfront for you. So you just provide the details. Like in this case, I said, let's create a CRM system. We're going to say CRM. And actually, let's just test this as a base concept based on what Christina was saying, is that if you have an ontology base and a domain engineering style of design, all I want to do is I wanted to build me a CRM system. So let's see if it can figure out that if I just say CRM and I say analyze, the domain engineering capability behind the scenes will know that this is an enterprise acronym. It will know what a CRM normally would contain. You can describe it quite specifically if you wanted to. So you can go into a lot of detail of what you want to do, but you can literally provide it with a single word, and it will then attempt to create you a design that is most relevant to that acronym or that concept that you are working with. Once this is done, you can see we got a bunch of other things happening in the background, but let that works along. We'll come back to that in a second. So once that's kicked off, what it looks like is like this. So what you will do is you'll see a timeline. Here is an example of a Teradata model being generated for a telecommunications company. So if you want to use the concept, you'll see that it goes through a series of steps, and then I get to complete at stage 1, and then it moves into stage 2. And in the logs, we can clearly see that it works through a multi-layer structure that will detect the domain, detect the understanding of what it needs to do, standardize the conventions, work within the context of each convention, and only build out what is highly relevant to the context that is being created up front. And it will then slowly work its way through the steps. So sometimes this can take a lot of time. This might take as long as, you can see, it's been running for 14 minutes and that for about 42 minutes. So it might take as long as an hour for you to generate an entire system end to end, because what it'll do, it will take the existing scaffolds and the engineered environments, and it'll make sure that the templates that are being applied plus the code that is within that context are generated in a secure environment so that you can then deploy it afterwards so that you know that it's going to work for you. We'll come back to that. And then here's another example of when it's completed and what the job will do when it's completed. This is a virtual mobile operators CVM system. That's basically a customer value management environment, and I'll show you what that looks like in a second. You'll notice here that we looked at that earlier, the logs, but you see here it says pushed to GitHub. So what you have is a full round trip capability. So what you can do is you can provide your own GitHub key, repo, and it'll go and create the repo for you. And every time you do a generation or you make changes of any sort, it'll create a new pull request for you. And that pull request can then work alongside, let's say, alongside your existing Claude code or existing AI tooling, whatever you want to use. So the idea is that if you then add additional code or you want to change what you're doing, you can do it fairly easily from the code base. And I'll show you in a second what the code base structure looks like that is generated, because it creates all of the entry points and your additional AI tooling that you might want to use at the command line or other environments. It create those structures for you as well from the outset. So the other thing is you can download the zip right here if you want to install it locally. So like in this case, if we take this example of the CVM and you want to download it, what it'll do, it will package the entire deployment, including in this case, it was generated with a Docker container configuration and everything else that goes with that. And when all of that's done, you can download it and you can then run it in an environment where it's locally executable. So the thing is, if I don't open up, like in this case, I've just gone into Virtual Mobile Operator CVM system. I'm looking at the diagram here in PlantUML. So you can see here is the PlantUML source code. So if you have existing PlantUML or you want to create your own, it will do that for you. And it supports UML 2.1 or whatever the version is to be working on. It's the new version of UML. So it's got all of the definitions of your design that is being created in the class diagram. And then it creates all of the workflows and everything else that you then need to make sure that the app can be validated before you decide to generate it. Essentially, there's a complete set, including the systems diagram and the packaging of how that will be deployed inside a cloud environment or gets created for you in the project. In project settings, if you go to storage, you will see every time that you've generated the app or you generated synthetic data, these storage areas will stay there for you within your own storage bucket. And then if you want to share it on GitHub, you can configure it over here for sharing it with people. And versions is where you set up the GitHub. Like you see here, it shows publish it to GitHub. And every time you do a release or a change to the app, it keeps on creating a pull request with the versioning that's done automatically for you. So you can see the versions that you're working on that is part of your core AI generated infrastructure versus the pieces that you are adding, because you might be adding with an additional tool or by hand manually additional capabilities to your app. So you want to make sure that you don't break it every time that happens, so that the cycle of your software evolution is then tracked. And you can roll back to any of the versions within whatever the repo is that you are working in. So if I just go to the GitHub repo to show you what that looks like here's an example of a repo that sits within our Ecogenetic. So this is just our Ecosystem AI. Ecogenetic LLC is our holding company, but it just shows you our normal README. I've added that repo to our repository, and you can see it's being added here. There are a couple of others that are also in there. So you'll notice that it'll tell you that it was added by, in this case, this was updated 3 hours ago, and it will generate you all of the related documentation with a full description of everything that's going on inside your app. So like in this case, we asked it to generate us a virtual mobile operator client value management system. So it created the subscribers, the billing, the charging, the product management, all the various components that you would need to be able to run it. And then this app was generated using the default configuration. So it used React and Node and Mongo. That is probably, one of the most scalable architectures you can get in the context of this kind of app. And then you'll see here that it will show you that it's got full CRUD implementation with all of an examples of how the endpoints work and some outline of what the source code structure looks like that we'll look at in a moment. And then you'll see here that in branches, the moment that you do a pull request, you'll see here that it will show you that 3 hours ago, I made an update. And in that update, I can then go look at the pull request and I can then execute it. I think this one I've already executed. So it's already, I've already done this. But the point is it creates the documentation, the cycle, and everything for you as part of your project. And you just configure that in your configuration here, that you can tell it either GitHub or GitLab. You provide it with your repository URL with your GHP key that you get. And if you click on this link here, it'll tell you where to go inside GitHub to go assign that key to your repo, or you use your enterprise repo key, depending on what you want to use. And then you can decide also if you want to use GitHub source to build the version of the truth for you when you deploy it back into, let's say, a cloud target. So the concept is that if you think of the normal development lifecycle, is that you want to be able to start when you kick off a new project, or you want to add any new application, or you want to migrate an existing application. You want to be able to kick it off with a very standardized core infrastructure that is already in place for you, with all the security and everything being taken care of, naming conventions and the lot. And then you want to add to it. So what this tells you, that if you don't want to do that, you can just turn this GitHub off, and it'll then create you singular versions that you can export and then go do with it whatever you need to do with it. Otherwise, you can manage your GitHub repo. If you make updates, you can do publish now, and you can also decide if you want to create alternative branch structures for whatever that deployment is that you're doing, based on the configuration that is fit for your own implementation. The other thing to think about is that in the contextual prompting, what happens is that all of the rules that are related to your app can be placed here. Like in this case, cursor rules, cursor prompt, the Claude rules, Claude skills, Claude tasks, as well as a Claude prompt. If you wanted to use this to extend your app and you wanted to go and create the rules inside a target app, and I'll show you now, we already prepared that environment for you when you get your app at the end of a generation cycle that you can download, because you got access to the source code in its entirety. There's no private libraries or anything. Everything is accessible once it's generated for you. So that just means that once you've done all of the work in your app and you've looked at what you needed to do, you then want to make sure that you target it. And here's one that I've just targeted it just a moment ago. So I've selected, in this case, GCP. So when I go to GCP, you can see here that it'll show me the asset inventory. And the asset inventory basically are all the components that go into that particular architecture with the key that is used for that generation that is unique. So what we are working on, and that will be available probably in another month or so, is that you can set up your own cloud credentials, private cloud credentials on our enterprise license, and you can generate these things straight into your own private repos and private enterprise deployment environments, whatever you're doing that in, and especially if you want to work from a well-defined core architecture that is already in place for you. But you can see here that the Cloud Run service and the artifact registry and everything that's got to do with what you would need, the buckets, including in this case, it spins up a Mongo database for you. All of those components are done for you end to end, especially if you just click target, and I'll show you now what we do if we do it with another one. Then what you also have is that if you generated synthetic data previously, that synthetic data will sit in this selection list, and you can then update it. So if I go to this app at the moment, and we just open this app running, you'll see that it'll generate a URL based on a generic standard. So you can put that behind whatever the control unit is that you want to put it behind. If you've got an API layer or a secure layer, or you don't want to put it onto the internet, you've got it done. But it generates the certificates and the routing, and everything is done for you already in that cloud environment with a full secure architecture. Now, what you see here is essentially the front-end login for that particular app. And I generated this app with a multi-language option. So what you can do, if I just go to, let's go pick this app here, and I'll go to generate code, you'll see here that app supports English, Arabic, Chinese, and Turkish. So you can select the languages that are supported. You select your architecture that you want to target. In this case, I turned on that it must include in the generation all of my external AI tooling that I want to use, including my admin credentials. And it will then implement for you an entire environment that deals with the JWT certificate management and everything that is world best practice that are used by security companies to do this kind of thing without you having to go make mistakes and regenerate. So we've got an incredibly strict scaffold that gets created the whole time for the deterministic side. So you can just extend what you need to extend yourself beyond that. Anyway, so we did then do generate. You'll see that it'll then, in this case, it generated for different languages. So in the app, on the front, you'll then see that it's got these different options. If I do Arabic, you'll see that that is a right to left implementation. So we support right to left, top to bottom, left to right. When you log in, it'll be entirely in that language. And then you'll see that Turkish is back to left to right. Or you can take Chinese, and that will also do it in a simplified Chinese for you. And the entire app can be converted to whatever the languages that you want to use. So when we log in to this app, I provided a default login. I just said admin add AI. Select whatever I'm signing in with. Now I can see I've got my entire app, and everything in the app is accessible to me. So I can look at the entire app running with a dashboard that is pretty detailed and maybe too complete. You might, if you're going to go generate it yourself, have it separated by role, by implementation. We are working on that at the moment, the entire security architecture that you'll be able to just pick an item to say, include role-based management across the app for me. But for now, you'll see that it's created a singular dashboard, and it's then created various workflows that are pre-prepared for you based on your spec that you gave it, and there are enterprise forms. While we on this, let's just come back here, and you'll see here that we can provide it with seed data. Because I generated synthetic data before, and I go select seed data. Now what it'll do, it'll kick off a new job for me, and that new job will then add seed data to the app, because I want to be able to test what's going on in my application. So if we give it a minute or so, you'll see that it'll start popping in, and it'll just take a while to, because now it spins up a new cloud worker. The cloud worker is a temporary connection to the data set. It then takes the code that does our ingestion, and that ingestion code, by the way, is accessible. You can download it. It's a Python ingestion library that can generate whatever number of synthetic data points you want to generate and add it. You can see we're adding subscribers at the moment. So if I now go to subscribers, you can see that it's added some of those. And in the dashboard, even things like analytics are all pre-prepared for you. So what it does, it finds out what the best combination of things like statuses, categories, or numeric fields and the like are. And if I don't want to edit it, you can see that you got a full CRUD capability on the back of it, including selecting references and the like. So it basically creates the entire infrastructure for you with every single form in the application per class. So if we now want to use this externally, so you can see it's busy filling out the data for us. We can leave that to run for now. And you'll see here that it's got OpenAI and API endpoint. If I go to the endpoint, it now gives me access to the backend, and it's got the full documentation, the health checks, and everything that are available to you, including an MCP endpoint that I'll show you in a moment how it works. And if I go explore the documentation, you'll see that it's got for every single entity in that class, or the way that the class was seen as a business entity and then converted into data, the language that is used is all related to AI tools that can have access to this. So each one of these will be converted into an AI, a tool that links to an agent automatically for you. So if I want to just explain how that works now, if I take, well, I just go back to the app, and I'll go scroll down here, and I'll go generate an API key, and I'll generate an API key that's now only for my app privately. I'll copy that key, and I'll now go edit. I'll go and edit this is a Claude config for MCP. I'll save that key there, and I'll take the back end that I'm working with, and we go update our environment, and this is a virtual operator system. Yeah, that's the one that we put our back end in there. And now all I have to do is I'm going to go start up Claude, at least, not Claude Code. The Claude Code will be one of those elements you can look at. So now what it's done, in that configuration, if I go to connectors, you'll see that, and I'll scroll down, you'll see there is my virtual operator system, the one that I've just added the key for, that is currently online. So if I now want to access this app, all I would have to say, list my subscribers from virtual operator. So it should be able to detect I'm talking about an agent, and then based on that agent that I'm accessing, I can then allow that agent to access that MCP server because I added the key to the MCP configuration for Claude locally. It'll then go and pick up the subscribers. So it brought back 10 from the 25 subscribers. And these are essentially the same subscribers that I've got. And if I had to come back here and I had to access it, and let's say I try it from the server, this should fail now. So it'll fail. It'll tell me response 401, meaning that I need to provide it with an API key on this server if I wanted to access it. So if I come back to my server, I take that API key, I authorize my backend in the same way, and I want to go compare my data, and I want to link this API to anything else that I'm doing. You see there's all the data that I could access, and it retrieved 20 items for me. So the whole ability for you to take whatever data you have and then absolute consistent design across everything that is going on, like page number of items to search under the get. And then if I go to, let's say, Sims, and I do the same thing, you'll see it looks the same, it operates the same. I tried out, so there's no ways I think that developers can be this consistent over time and make sure that the language is reliable. But it does essentially the entire implementation for you with all the discipline, and you've got access to this data from any other API infrastructure that you might need access to. So you'll now notice that our data synthetic generator has gone through and populated all of our data with the sample data to be generated. And if I then go to enterprise forms, like in this case, it gives me a list of subscribers. I can select that subscriber, look at the KYC record, and then you'll see that it'll generate me analytics that is normally across a number of different relationships. So this also can be extended if you want to go look at the code yourself and extend that further. So you could look at various ways that you can analyze your data, and you'll see that it'll work out based on, like, that's a time series data set that knows when there's a date and a kind of a category that you would want to do away some kind of categorization, and here's a distribution that you want to probably view typically in this kind of environment. So the basic concept is that you now create, and from the beginning, you just pointed it to a certain target architecture. So what you do is you do it like this. You select a target architecture, you pick your repo. In this case, it was a GitHub repo that we're busy using as our main repo. So we would have merged that branch that would maybe change, or maybe you've done local code changes and you've merged it into that branch. It'll always be in the main. So whatever new code gets generated through our environment, this gets merged, and your code never gets destroyed ever. It always stays there. We place documentation inside all of our code. So here's an example of a environment that was generated. And actually, let me just see if my download would have kicked off. We'll get back to that in a second. I don't know why my download didn't kick off. Okay, let's just look at this one. Here's an example. Here's another one that we created called Workday Human Management. You'll see here that it created the cursor rules. There is an ecosystem code definition with a manifest, and the manifest essentially shows you the metadata of the app so that you can control the manifest later on if you wanted to see what is being changed. And you want this manifest, especially if you use external AI tools, so that they will know what to do and where to do it, so that they don't break anything. So the practices that are being encapsulated in this code generation, every time that you do it, is every time we learn more practices and more ways of handling the discipline in this deployment, we add it to the core generation. So the concept is that you can come back and generate your app again in, let's say, a month from now or a week from now, and it will have all of the new capabilities embedded in the new generated app that you've created. You'll see here that that's the environment file with all the security components in it. That is a practice that you would use in this context. There's the cursor prompt and the Claude prompt and Claude MD. The Claude MD is that if you had to do a Claude and then a /init, it'll pick up this Claude, and it highly likely probably will recommend additions for you, because it often would analyze it and make recommendations to make it even better. And then you'll also see here that the start files are made for various operating systems. So it'll work on this case, it will run in a Unix environment, Unix, Mac, all the same. And then they have a version for Windows as well that'll comply with a Windows-based deployment. And the script is fairly strict around what it looks for and how it deals with port conflicts, checking that certain parts are running. So the practices that are used in here, you don't have to go build it by hand, but you have full access to it if you wanted to use it for this project or for another. And you'll see that we update these continuously, because they typically something that you want to make sure that complies with new security standards and the like. So every time there's a new security update, whatever it might be, you just come in, you regenerate your app or generate your core infrastructure with all of the new updates. And that's kind of the case for wanting to stay on ecosystem code long term, because what you want to do is that the amount of money you're going to spend and the hours you're going to burn to fix the generics are just too long. So this makes it easy for you to, just to get it from us. The other thing that it does is that you'll see here that the language implementation is separated. And we did a lot of thinking around this. Even though it's duplicated, we wanted to make sure that that language implementation could then be updated or changed by you. And there's an extension when you look at, if you open up any code that is being generated already, and when you open it, you'll see that the descriptions in those environments will explain to you. Let's just go open with Visual Studio. You'll see here that it says generated by ecosystem code, platform code, per user changes and extension layer. So it'll always tell you that you mustn't make this, don't change this. If you wanted to get your ongoing security upgrades and everything from us, then don't change it there. The other thing is that you'll notice that there's a source here. That means this is the total highly disciplined structure that have separated the implementation, including like the MCP implementation and the like, and MCP security. For those who know, this is being, changing as we implement all of these tools over time. So there are a whole lot of updates that we're working on at the moment that are going to be deployed in the next few weeks. So when you generate the app, it'll have all of the latest security standards implemented with everything that comes with that. But that just means that all this work is done for you, and it's done consistently within a very disciplined environment. If you wanted to run the app locally, all that you do, like in this case, I just create a new terminal at where I'm at, and I just do a start.sh. And whenever you run start, what it'll do, it will install all the dependencies for you. It will run the entire infrastructure, and you can then also use our Terraform if you wanted to go do a manual push to your own personal cloud environment. It can also be done from here. But the point is that it generates the entire environment right to the end that you can then go and select it and run an app that is locally accessible. And then every time that you regenerate, you just have to say that generate from Git repo, because you might have made changes and updates, and it'll then repackage it for you with the new core rules in place. Don't mess with your code, it will combine it. And then when I open up this app, you'll then see that it'll open up that same environment. This particular app only has Turkish and English. The thing is that you can go select what you want to do there. Okay, so let's just close that. When I kill it, it'll remove all the resources, Docker and so on, and then I can go back to my app. So what you can see here, just to go back to the Claude environment that it's connected to, you'll see here that when it did the integration, it went and found the tools from our backend that was sitting in this case on the cloud, and I gave it the key that's locally verified. So this front end could have been running inside your enterprise, where you run it with a model that sits in your own estate, and then you can just connect to our backend to do all of the work for you. And you can see here there are 10 of the ones that you see from our current configuration. If it can't access anything, and you look at the top here, it says there runtime offers local. This is a local test environment. You'll see this kind of error if your environment is not working, and then you can go to the Claude logs to go see what's wrong. But we've tested this extensively, so it's always accessible from whenever you want to access it, and depending on what you have generated. Yeah, so in this case, if we want to generate for a different environment, and let's say we pick like Microsoft Azure, and I go create, you'll see that it creates a deploy. This is the current one already in production running. You'll see here, when you click on Mongo, you'll see the key that you can connect to the database that is generated for you. You can connect to that target database from within your own infrastructure. And if you run, let's say, the ecosystem.ai environment, you can connect to that Mongo. If you wanted to use chat to SQL or any one of those kind of capabilities, you can connect straight to that backend that does all of the implementation from a database connectivity, as in the secure connection can be done from the key that was created through our generation environment. So this is what happens here. In this case, it shows you job is 55%, the backend image is being created. If I click on the assets, you see there are no assets being logged yet. And in this case, the source is GitHub. And when it's up and running, we'll be able to open it up. So what it does, it uses the core app execution environments in those cloud providers that we support. So AWS, GCP, as well as Azure. So you can decide where you target it. So that means that unless you really want to change it, you don't need to do any architecture or additional technical work to get any of that capability done, because you got the entire infrastructure being created for you. Yeah, and I think that's really my story. We can wait for a lot of these things to complete, but you get the picture. And that just means that when you have your running app and you make changes to it, and you can then, once you're done with it and you want to go rebuild it, you'll see here that there's an update function. All that you do is when you've made changes to your repo, if it's connected to a Git repo, you just come in here and you click update. If you click update, you can then decide if you want to do user interface backend or database changes. So what we probably want to do is keep database off. If you already have an existing database with all of your current data in it, and let's say you're busy replacing your favorite CRM system or your favorite accounting system or your favorite contract management system or procurement system, whatever you're busy replacing, and you have existing data, you just have to turn that off. And you don't want to go and sit through an AI tool to say, please don't touch that data. And you've seen all of those stories popping out where these things will go do, all kinds of actions. You just never know what it's doing. But in this case, you just tell it not to do that. It's deterministic. It's not going to do it. It's only going to focus on where the context gets set and only work on those areas for you. But in this case, it will go and destroy the infrastructure, regenerate the environment for you, and push it back onto that cloud, spin it up again, and you can then go and access whatever you've made updates to. And it might be worthwhile maybe for us in the future, we can show a demo of maybe just that, of how that round trip R&D can take place if you wanted to do a lot of that within your own environment, or you run it locally with Claude Code or Cursor or Windsurf, what do you run? And then you push it up into your repo and then just coming back here and just click generate and it then hosts the app for you. And then once it's running and it's accessible, what you'll find is that everything that is busy updating. So let's just check, we'll wait for that to finish. And then the thing is that when it's done and you've done whatever changes you've made, and in this case, you can see it, from a database point of view, it takes a little bit of time to prepare it for you. You can then have a full round trip capability in your deployment of your apps. Okay, I think I'll leave it at that for now, Christina. So we can wrap up on the back of that.
I think that's actually a great way to end things off. And I hope everyone, as much as myself, is excited to try the new features and integrations and capabilities of ecosystem code as we add onto them, which is very exciting. I'm going to open up the floor then to any questions that we may have from the audience so far. I've also dropped our link to our Discord channel. If you have any questions as you build, our team is readily available to address those as well. And then you can also keep up with any features and updates on there. So yeah, any questions?
No questions today, Christina. I think everybody are very happy with it.
I wasn't ready to jump onto the workbench and get started. Thank you all so much for joining today. Like I said, the link is available in the chat for you to join our Discord channel. If you have any questions at a later stage, you're more than welcome to contact us on Discord and we're happy to help. And this recording will be available on our YouTube channel for any future catching up that is also highly recommended. Thank you everyone so much.